Imagine Earth as a giant robot apple, shiny, metallic, and full of complex machinery. Humans? We are just tiny passengers clinging to the fragile peel. We might think our planet is solid and unchanging, but beneath our feet lies a fiery secret. Earth's core is a blazing furnace as hot as the surface of the sun itself. We are separated from this inferno by a surprisingly thin crust. Think of it like an eggshell protecting a fragile yolk. It's a delicate balance between immense heat and the cool surface we call home. This is where our journey begins, into the heart of our world. Underneath the continents and oceans, the Earth is far from uniform. Like a carefully crafted cake, it is made up of distinct layers. At the very center lies the inner core, a solid sphere of iron squeezed under unimaginable pressure. It's so dense that even Superman would struggle to dent it. Surrounding this iron heart is the outer core, a swirling ocean of molten iron and nickel. This liquid metal is constantly on the move, creating a spectacle of heat and energy. Above this lies the mantle, a thick layer of hot, dense rock. It's like a slow-moving conveyor belt, responsible for the movement of continents and the rumbling of earthquakes. Finally, we reach the crust, our home, a thin, fragile skin compared to the vast depths below. It's a humbling thought that all of human history has unfolded on this relatively tiny layer of rock. Deep within Earth's core, something incredible is happening. The outer core, a sea of molten iron and nickel, is in constant motion. Heated from below and cooled from above, this liquid metal churns and flows in a process called convection. It's like a giant pot of boiling water, but on a planetary scale. This constant motion is what gives Earth its magnetic field. As the liquid metal flows, it creates electric currents. These currents, in turn, generate a magnetic field that extends far out into space. It's an invisible force field, a shield that protects us from the dangers of the cosmos. Imagine a constant stream of charged particles known as the solar wind blasting out from the sun. This solar wind would strip away our atmosphere and bombard the surface with harmful radiation if it weren't for our magnetic field. It acts like a giant shield, deflecting most of these particles around our planet. Without this protection, Earth would be a barren, lifeless wasteland. Our atmosphere would be stripped away, oceans would boil off into space, and the surface would be exposed to the full fury of the sun's radiation. It's a sobering thought that our very existence depends on the constant churning of molten metal thousands of miles beneath our feet. The magnetic field isn't just a static barrier, it's a dynamic and ever-changing force. It waxes and wanes, shifts and dances in response to the sun's activity. And sometimes it does something even more dramatic. It flips. That's right, Earth's magnetic field has reversed itself many times throughout history. North becomes south, and south becomes north. These reversals are recorded in the rocks themselves, a hidden history of our planet's magnetic past. While we don't know exactly what triggers these flips, they are a reminder of the dynamic nature of our planet's core. Recently, scientists have noticed something strange. The inner core, which spins slightly faster than the rest of the planet, seems to be slowing down. It's like Earth's heartbeat is losing its rhythm. The reasons for this slowdown are still a mystery. Is it a temporary blip or a sign of something more significant happening deep within our planet? This question has profound implications. The Earth's core is a delicate engine, and any changes in its behavior could have ripple effects on the surface. Understanding these changes is crucial to our future. The study of Earth's core isn't just about understanding our own planet. It's also about understanding other worlds. Take Mars, for example. Once a planet with flowing water and a thicker atmosphere, it's now a cold, dry desert. What happened? The answer lies in its core. Mars lost its magnetic field billions of years ago, perhaps due to its smaller size and faster cooling. Without this protective shield, the solar wind stripped away its atmosphere and blasted its surface with radiation. It's a stark reminder of how important a magnetic field is for life as we know it. By studying Earth's core, we can learn about the fate of other planets, both in our solar system and beyond. It's a humbling thought that the secrets of the universe are hidden not just in the vastness of space, but also deep within our own world. So the next time you feel the ground beneath your feet, remember the incredible forces at work beneath the surface. Earth is not just a giant robot apple, it's a complex and dynamic system, a delicate dance of fire and stone. And it's up to us to unlock its secrets and ensure the well-being of our fragile home.